97%. That was the market's confidence that the 2008 housing market would hold. Credit default swap pricing implied a mere 3% probability of a systemic collapse. One bank disagreed. They updated their probability estimate using new data on subprime default rates. Their revised estimate? Now, 40%. They bet billions against the housing market and made one of the largest single trade profits in Wall Street history. The difference between 97% confidence and bankruptcy was one concept: updating probabilities with new information. That concept has a name: Bayes' theorem. Probability is not just theory for the CFA exam. It is the foundation of every risk model, every valuation, every portfolio decision you will ever make. If you cannot calculate the probability of an event, you cannot price it. If you cannot price it, you cannot manage the risk. In this lesson, you will master every probability concept the CFA exam tests. We start with the three types of probability, then conditional versus unconditional probability, and the rules for combining them. Bayes' theorem, which is by far the most tested topic in this reading, expected value and variance for investments, portfolio expected return and variance, and counting methods, combinations, and permutations. 5 exam questions with full wrong answer analysis at the end. Probability concepts. Lesson 5 of CFA Level 1, Quantitative Methods. Part 1. Types of probability. Where do probabilities come from? A probability is a number between 0 and 1 that measures how likely an event is to occur. 0 means impossible. 1 means certain. Everything interesting happens in between. There are 3 ways to assign a probability to an event. First, a priori probability. This is probability determined by logic and reasoning before looking at any data. A fair coin has a 50% probability of heads, not because someone flipped it a million times, but because there are 2 equally likely outcomes, and heads is one of them. A priori probability uses this formula. The probability of event A equals the number of favorable outcomes divided by the total number of equally likely outcomes. This only works when outcomes are equally likely. A fair die gives each face 1/6. A loaded die does not. Second, empirical probability. This is probability estimated from observed data. If you analyze 30 years of S&P 500 returns and find that the market was up in 22 of those years, you estimate the probability of a positive return year as 22 divided by 30, or 73%. Empirical probability has a weakness. It assumes the future will resemble the past. If market conditions change fundamentally, as they did in 2008, historical frequencies become unreliable. The formula is the same structure. Probability of A equals the number of times A occurred divided by the total number of observations. Third, subjective probability. This is a personal judgment, an informed estimate based on experience, intuition, and analysis, but not derived from a formula or frequency count. When an analyst says there is a 60% chance the Fed raises rates at the next meeting, that is subjective probability. There is no formula. There are not hundreds of identical Fed meetings to calculate a frequency from. The analyst combines their understanding of economic data, Fed communication, and historical patterns into a single number. Subjective probability is the most common type in finance. Almost every forward-looking estimate, from earnings forecasts to credit ratings, involves subjective probability. The CFA exam tests whether you can identify which type of probability is being used. The key is the source. Logic gives a priori, data gives empirical, judgment gives subjective. Here is the exam decision rule. If the probability comes from counting equally likely outcomes, it is a priori. If it comes from historical data and frequency counts, it is empirical. If it comes from an analyst's judgment or personal assessment, it is subjective. The trap on the exam is the word estimate. An empirical probability is also an estimate because it is based on a sample of data. But it is estimated from data, not from personal judgment. If the question says based on historical returns, that is empirical. If it says the analyst believes, that is subjective. Part 2. Conditional and unconditional probability. The most important distinction in probability. Unconditional probability is the probability of an event without any additional information. The probability that a stock goes up tomorrow, period, no conditions attached. Conditional probability is the probability of an event given that another event has already occurred or is known to be true. Probability that a stock goes up tomorrow, given that the Fed cut rates today. The notation matters. P of A is unconditional. P of A given B, written P of A vertical bar B, is conditional. That vertical bar means given. Everything to the right of the bar is what you already know. Everything to the left is what you are calculating. Conditional probability is the foundation of investment analysis. You never estimate returns in a vacuum. You always condition on what you know. Earnings surprise? Condition on it. Recession indicator flashing? Condition on it. Every piece of new information changes the probability. The multiplication rule connects joint probability, conditional probability, and unconditional probability. The probability of A and B both occurring equals the probability of A given B, multiplied by the probability of B. P of A and B equals P of A given B times P of B. Think of it as a two-stage filter. First, what is the probability of B happening? Then, given B happened, what is the probability that A also happens? Multiply those two stages together and you get the joint probability of both occurring. You can also write it the other way around. P of A and B equals P of B, given A times P of A. Both are correct, both give the same answer. Let us apply this. Suppose the probability of a recession is 30%, and the probability that a stock declines given a recession is 70%. What is the probability that we have both a recession and the stock declines? Step 1. Identify the pieces. P of recession is 0.3. P of stock declines given recession is 0.7. Step 2. Apply the multiplication rule. P of recession and stock declines equals 0.7 times 0.3, which is 0.21. 21% probability that both events occur. This is the joint probability, not the probability of one or the other, but both happening together. The addition rule tells you the probability that at least one of two events occurs. P of A or B equals P of A plus P of B minus P of A and B. Why do we subtract P of A and B? Because when we add P of A and P of B, we double count the overlap. The scenarios where both happen get counted once in P of A and again in P of B. Subtracting the intersection removes the double counting. If A and B are mutually exclusive, meaning they cannot both happen, then P of A and B is 0. The formula simplifies to P of A plus P of B. This is a common exam trap. They give you mutually exclusive events and expect you to recognize that the intersection is 0. Part 3. Independence and mutual exclusivity. Two concepts. The exam loves to test together. Two events are independent if knowing one tells you nothing about the other. Formally, A and B are independent if P of A given B equals P of A. Learning that B happened does not change the probability of A. For independent events, the multiplication rule simplifies. P of A and B equals P of A times P of B. No conditional probability needed. Just multiply the two unconditional probabilities. Example, the probability that the S&P is up today is 53%. The probability that it rains in London today is 40%. These events are independent. Whether it rains in London tells you nothing about the S&P. The probability of both occurring? 0.5 3 times 0.4 equals 0.212, or 21.2%. Two events are mutually exclusive if they cannot both happen. If A occurs, B cannot occur. If B occurs, A cannot occur. P of A and B equals 0. Example, a bond is rated either investment grade or junk. It cannot be both simultaneously. These are mutually exclusive. Here is the critical exam trap. Mutually exclusive events are not independent. They are the opposite. If I tell you that A happened, you immediately know B did not happen. That means knowing A gives you perfect information about B. P of B given A equals 0, which is not equal to P of B. So the events are dependent, not independent. The exam will test this distinction directly. If two events are mutually exclusive with non-zero probabilities, they cannot be independent. If two events are independent, they cannot be mutually exclusive unless one has probability 0. Part 4. The total probability rule. The bridge to Bayes' theorem. The total probability rule lets you calculate the unconditional probability of an event by considering all the different scenarios that could produce it. P of A equals P of A given B1 times P of B1 plus P of A given B2 times P of B2, and so on for every scenario. The B scenarios must be mutually exclusive and exhaustive. That means they cover every possibility and do not overlap. Think of it like this. You want to know the overall probability that your portfolio declines. There are two scenarios, recession and no recession. These are mutually exclusive and exhaustive. You know P of portfolio decline given recession and P of portfolio decline given no recession. The total probability rule combines these conditional probabilities weighted by how likely each scenario is. Let us compute the total probability of a stock declining. Scenario 1, recession. Probability of recession is 30%. Probability the stock declines given recession is 70%. Scenario 2, no recession. Probability of no recession is 70%. Probability the stock declines given no recession is 20%. Apply the formula. P of stock decline equals P of decline given recession times P of recession plus P of decline given no recession times P of no recession. That is 0.7 times 0.3 plus 0.2 times 0.7. 0.21 plus 0.14 equals 0.35. 35% overall probability of a stock decline. We weighted each conditional probability by the probability of that scenario. This is the unconditional probability. Part 5. Bayes' theorem. The single most tested concept in this reading. Bayes' theorem answers this question. I had a prior belief about the probability of an event. New information just arrived. How should I update my belief? The formula. P of B given A equals P of A given B times P of B divided by P of A. Let us break this down. P of B is your prior probability, what you believed before the new information. A is the new information that arrived. P of A given B is the likelihood. How probable is the new information? I if your original belief is true. P of A is the total probability of the new information under all scenarios. This is where the total probability rule feeds in. P of B given A is your posterior probability, your updated belief after incorporating the new information. The entire structure is prior times likelihood divided by evidence equals posterior. Here is the classic CFA exam Bayes question. A company's earnings can either beat estimates or miss estimates. The prior probability of beating estimates is 60%. An analyst's model predicts a beat. When the company actually beats, the model correctly predicts a beat 80% of the time. When the company actually misses, the model incorrectly predicts a beat 30% of the time. Given the model predicts a beat, what is the updated probability that the company actually beats? Step 1. Define the events. B is the company beats. A is the model predicts a beat. Step 2. List what you know. P of B, the prior, is 0.6. P of A given B, the likelihood, is 0.8. P of miss is 0.4. P of A given miss is 0.3. Step 3. Calculate P of A using total probability rule. P of A equals 0.8 times 0.6 plus 0.3 times 0.4, which is 0.48 plus 0.12 equals 0.6. Step 4. Apply Bayes. P of B given A equals 0.8 times 0.6 divided by 0.6, which equals 0.8. The posterior probability is 80%, up from the prior of 60%. The model's prediction increased our confidence. Let us make sure you understand why Bayes works the way it does. Imagine 100 companies. 60 beat estimates, 40 miss. Of the 60 that beat, the model correctly predicts a beat for 80%, which is 48 companies. Of the 40 that miss, the model incorrectly predicts a beat for 30%, which is 12 companies. So the model predicts a beat for a total of 60 companies. 48 were actual beats. 12 were false positives. Given the model said beat, what fraction actually beat? 48 out of 60, which is 80%. That is Bayes' theorem. It is just counting in disguise. You are figuring out what fraction of the model's positive predictions are true positives. Every Bayes problem can be solved by imagining 100 or 1,000 cases and counting. If the formula confuses you, use the counting approach. Part 6. Expected value and variance. From probability to investment decisions. The expected value is the probability weighted average of all possible outcomes. E of x equals the sum of each outcome times its probability. P1 times x1 plus P2 times x2, and so on. This is not the outcome you expect to observe most often. It is the long-run average if you could repeat the experiment infinitely. For investments, expected return is calculated the same way. If there is a 40% chance the stock returns 15%, a 35% chance it returns 8%, and a 25% chance it returns negative 5%. The expected return is 0.4 times 15 plus 0.35 times 8 plus 0.25 times negative 5, which equals 7.55%. 7.55% is not a guarantee. It is your best single number summary of all possible outcomes weighted by their likelihood. Variance measures the dispersion of outcomes around the expected value. Variance of x equals the sum of each probability times the squared deviation from the mean. P1 times x1 minus e of x squared plus P2 times x2 minus e of x squared, and so on. Why do we square? Because deviations above and below the mean would cancel out if we just added them. Squaring makes everything positive, so the cancellation cannot happen. Standard deviation is the square root of variance and is in the same units as the original data. Variance is in squared units, which is not intuitive. If returns are in percent, variance is in percent squared. Standard deviation brings it back to percent. Let us calculate expected return, variance, and standard deviation for an investment. 3 scenarios. Boom. 40% probability, 15% return. Normal. 35% probability, 8% return. Recession. 25% probability, negative 5% return. Expected return. 0.4 times 15 plus 0.35 times 8 plus 0.25 times negative 5. 6 plus 2.8 minus 1.25 equals 7.55%. Variance. 0.4 times 15 minus 7.55 squared plus 0.35 times 8 minus 7.55 squared plus 0.25 times negative 5 minus 7.55 squared. 0.4 times 55.50 plus 0.35 times 0.20 plus 0.25 times 157.50. 22.2 plus 0.07 plus 39.38 equals 61.65. Standard deviation is the square root of 61.65, which is 7.85%. So the expected return is 7.55% with a standard deviation of 7.85%. Part 7. Covariance and correlation. How two investments move together. Covariance measures how two variables move together. Covariance of x and y equals the sum of each probability times the deviation of x from its mean times the deviation of y from its mean. If x is above its mean when y is above its mean, the product is positive. Positive covariance means they move in the same direction. If x is above its mean when y is below its mean, the product is negative. Negative covariance means they move in opposite directions. The problem with covariance is that its magnitude depends on the units of x and y. A covariance of 500 between two stock returns sounds large, but is it? You cannot tell without knowing the scale. Correlation solves the scale problem. The correlation coefficient equals covariance of x and y divided by the standard deviation of x times the standard deviation of y. Correlation is bounded between -1 and +1. +1 means perfect positive linear relationship. They always move in the same direction by proportional amounts. -1 means perfect negative linear relationship. They always move in opposite directions. 0 means no linear relationship. Correlation is the most important input in portfolio construction. When you combine two assets with low or negative correlation, the portfolio risk is less than the weighted average of individual risks. That is diversification, and it is only possible because of imperfect correlation. Part 8. Portfolio expected return and variance, where probability meets portfolio construction. The expected return of a portfolio is simply the weighted average of the expected returns of its components. E of RP equals W1 times E of R1 plus W2 times E of R2. If you put 60% in stocks with an expected return of 10% and 40% in bonds with an expected return of 4%, the portfolio expected return is 0.6 times 10 plus 0.4 times 4, which is 6 plus 1.6 equals 7.6%. Simple weighted average. Nothing surprising here. Portfolio variance is where the magic happens. Variance of RP equals W1 squared times sigma 1 squared plus W2 squared times sigma 2 squared plus 2 times W1 times W2 times sigma 1 times sigma 2 times rho. The first two terms are the individual risk contributions. The third term is the interaction term that depends on correlation. When rho equals +1, correlation is perfect, and the portfolio standard deviation is simply the weighted average of the individual standard deviations. No diversification benefit. When rho is less than +1, the portfolio standard deviation is less than the weighted average. This reduction is the diversification benefit. When rho equals -1, you can theoretically create a zero-risk portfolio by choosing the right weights. This is the maximum diversification possible. This formula is the mathematical proof that diversification works. A portfolio with 60% stocks and 40% bonds. Stocks. Expected return 10%, standard deviation 15%. Bonds. Expected return 4%, standard deviation 5%. Correlation between them is 0.2. Expected return. 0.6 times 10 plus 0.4 times 4 equals 7.6%. Portfolio variance. 0.6 squared times 15 squared plus 0.4 squared times 5 squared plus 2 times 0.6 times 0.4 times 15 times 5 times 0.2. 0.36 times 225 plus 0.16 times 25 plus 2 times 0.6 times 0.4 times 15 times 5 times 0.2. 81 plus 4 plus 7.2 equals 92.2. Portfolio standard deviation is the square root of 92.2, which is 9.6%. Notice, the weighted average of the individual standard deviations would be 0.6 times 15 plus 0.4 times 5, which is 11%. But the actual portfolio standard deviation is only 9.6%. That gap of 1.4% is the diversification benefit, and it exists because the correlation is less than 1. Part 9. Counting methods, combinations, permutations, and the factorial. When order matters, use permutations. The number of ways to arrange R items from a set of n items, where order matters, is n factorial divided by n minus r factorial. Factorial means multiply all integers from n down to 1. 5 factorial is 5 times 4 times 3 times 2 times 1, which is 120. Example, you have 10 stocks and want to rank your top 3, first place, second place, third place. The number of possible rankings is 10 factorial divided by 7 factorial. 10 times 9 times 8 equals 720 possible rankings. Order matters because ranking Apple first and Google second is different from ranking Google first and Apple second. When order does not matter, use combinations. The number of ways to choose R items from n items, where order does not matter, is n factorial divided by r factorial times n minus r factorial. This is the permutation formula divided by r factorial, because we are removing the duplicate orderings. Example, you want to choose 3 stocks from 10 for a portfolio. You do not care about the order, just which 3 you pick. C of 10, 3 equals 10 factorial divided by 3 factorial times 7 factorial. That is 720 divided by 6, which is 120 possible portfolios. The exam decision rule. If the question says select, choose, or pick a group, it is combinations. If the question says rank, order, or arrange, it is permutations. Labels like first, second, third mean order matters. A group of 3 with no labels means order does not matter. Let us return to the 2008 financial crisis for a moment. In 2006, the market assigned a prior probability of roughly 3% to a systemic housing collapse. Then new data started arriving. Subprime default rates doubled, then tripled. Most market participants ignored this data or rationalized it away. They did not update their priors. One hedge fund manager applied Bayes' theorem systematically. New data on subprime defaults was the evidence. A housing collapse was event B. P of seeing these default rates given a housing collapse was extremely high. P of seeing them given no collapse was low. Bayes told him the posterior probability of collapse had risen from 3% to over 40%. He bought credit default swaps when they were priced for 3% probability and collected when the 40% scenario materialized. This is why probability matters. It is not abstract math. It is the difference between seeing what the data is telling you and ignoring it because your prior is too comfortable. Part 10. CFA practice questions. 5 questions, full wrong answer analysis. Question 1. Events A and B are mutually exclusive. P of A is 0.3 and P of B is 0.5. What is P of A or B? Take a moment to work this out. If you chose 0.8, you are correct. Because A and B are mutually exclusive, P of A and B equals 0. The addition rule simplifies to P of A plus P of B, which is 0.3 plus 0.5 equals 0.8. If you chose 0.65, you used P of A plus P of B minus P of A times P of B. That formula assumes independence, not mutual exclusivity. Mutually exclusive events have a joint probability of 0, not P of A times P of B. If you chose 0.15, you calculated the joint probability P of A times P of B. But A and B are mutually exclusive, so the joint probability is 0, and the question asked for P of A or B, not P of A and B. Question 2. A screening test for a disease has the following properties. If a person has the disease, the test is positive 95% of the time. If a person does not have the disease, the test is positive 10% of the time. The prevalence of the disease in the population is 2%. A randomly selected person tests positive. What is the probability they actually have the disease? This is Bayes' theorem. If you chose 16.1%, you are correct. P of disease given positive test equals P of positive given disease times P of disease divided by P of positive. The numerator is 0.9. 5 times 0.02 equals 0.019. P of positive is 0.9 5 times 0.02 plus 0.10 times 0.98 equals 0.09 plus 0.88 equals 0.118. So P of disease given positive is 0.019 divided by 0.118 equals 16.1%. If you chose 95%, you confused P of positive given disease with P of disease given positive. That is the most common Bayes error. Just because the test is 95% accurate does not mean a positive result gives a 95% chance of disease. Question 3. 2 events, A and B, are independent. P of A is 0.4 and P of B is 0.6. What is P of A and B? If you chose 0.24, you are correct. For independent events, P of A and B equals P of A times P of B, which is 0.4 times 0.6 equals 0.24. If you chose one, you added the probabilities. Addition gives P of A or B, not P of A and B. If you chose 0, you confused independence with mutual exclusivity. Independent events can happen together. Mutually exclusive events cannot. This is the single most tested distinction in probability. Question 4. Portfolio is 60% stocks and 40% bonds. The expected return on stocks is 12% with a standard deviation of 20%. The expected return on bonds is 5% with a standard deviation of 8%. The correlation between stocks and bonds is 0.25. What is the portfolio standard deviation? If you chose 13.2%, you are correct. Portfolio variance equals 0.6 squared times 20 squared plus 0.4 squared times 8 squared plus 2 times 0.6 times 0.4 times 20 times 8 times 0.25. That is 0.3, 6 times 400, plus 0.1, 6 times 64, plus 2 times 0.6 times 0, 0.4 times 20 times 0.25. 144 plus 10.24 plus 19.2 equals 173.44. Square root of 173.44 is 13.2%. If you chose 14.8%, you calculated the weighted average of standard deviations, which ignores the correlation benefit. Diversification reduces risk below the weighted average whenever correlation is less than +1. Question 5. A committee of 3 analysts must be chosen from a group of 8. How many different committees are possible? If you chose 56, you are correct. This is a combination problem because the order does not matter. A committee of Alice, Bob, and Charlie is the same committee as Charlie, Alice, and Bob. C of 8, 3 equals 8 factorial divided by 3 factorial times 5 factorial. 8 times 7 times 6 divided by 3 times 2 times 1 equals 336, divided by 6 equals 56. If you chose 336, you calculated the permutation. That would be the answer if order mattered, like if you were assigning president, vice president, and secretary roles. But the question says a committee, which means no ordering, so use combinations. Here is your probability concepts cheat sheet. Screenshot this. Save it, review it before exam day. Every formula, every rule, every trap, all on one screen. Here are the exam patterns to make automatic. When you see mutually exclusive, the joint probability is 0. When you see independent, the joint probability is the product of the individual probabilities. Mutually exclusive and independent are never the same thing. If 2 events with non-zero probabilities are mutually exclusive, they are dependent. When you see a Bayes question, write 4 numbers immediately. Prior P of B, complement 1 minus P of B, likelihood P of A, given B, false positive P of A given not B. Then total probability rule for the denominator, then divide. When you see select or choose a group, use combinations. When you see rank, arrange, or assign roles, use permutations. These patterns repeat on every exam. Make them reflexes. That is, probability concepts. Next lesson, we tackle common probability distributions. Normal distribution, binomial distribution, and the tools that power every risk model in finance. Subscribe so you do not miss it. If this lesson helped, drop a like. It pushes the algorithm to show this to more CFA candidates who need it.